Welcome to this video on Kofax RPA. My name is Jesper Scherpenhauser and today I want to talk about robot lifecycle management. And you'll hear me talking about things like Git, version control. You'll hear me talk about all of those things like commits, commit messages, you name it. And in today's video, I do want to take a bit more of a structured approach where we first want to talk about, why is RLM that important? Where did it come from? And how did we actually implement it? Why did we implement it like this? And what's the actual business benefit of this approach as well? And then, of course, I want to close off with a demo and actually show you how easy it is to implement, and also how easy it is to then drive value for you and your organization. As always, I'm not going to deep dive into things like Git and version control and best practices in that regard. If you have any questions on that, let me know and I'm more than willing to help you guys out. But the internet is full of people who know a lot more about these topics than I do, so feel free to reach out to them as well. And if you have any combined questions, then come to me. So that being said, let's dive in, shall we? So the first question is, of course, why is RLM, robot lifecycle management, such a hot topic nowadays? And the reason for that is, of course, on the one hand, you have Kofax RPA, which is tremendous at taking robotics to scale, go beyond the simple 50, 500 robot use cases, but truly scale at 5,000, 50,000, hundreds and hundreds of thousands of robots. And Kofax RPA is, of course, more than capable of handling that. What it doesn't have is version control. It doesn't have a lifecycle management capability there, an approval workflow for robots. And what we actually saw in some of our enterprise customers, so to say, is that they started to leverage industry standard tools to do exactly that. So where we saw them just jotting robots into Git or into SVM, and we saw, we can of course do a lot of legwork and implement a similar feature ourselves, or we could choose not to reinvent the wheel and actually just stand on the shoulders of these giants and make sure that we can directly integrate with them. And that is exactly what RLM, that's been released, if I'm not mistaken, since 10.5 a year and a half ago. So it's been there for quite some time now, and I want to show you how easy it is to do that. And for that, I'm just going to talk a bit more about the actual architecture, how the actual flow of robots actually is, where the Kofax RPA product stops and where Git actually takes over. And there you have it. So we are indeed offering that out-of-the-box integration with Git repositories. And of course, Git has been around for quite some time, and it has become the absolute industry standard when it comes to distributed version control. And Git is, of course, one of those offsprings from Linus Torvalds, who is probably best known for being the initial developer for Linux. And he actually needed a version control platform to build and to work on the Linux kernel, which is of course this great big monolithic behemoth of code, and he needed something that was distributed, that could scale. And then he said, these are the things I need to do, and we need to have a solution for that. And that's the whole genesis of Git, actually. If we talk about things that need to be able to scale, work in a distributed environment, that sounds very familiar for those of you who've been interacting with Kofax RPA at an enterprise scale, of course. So we use that, and we have now built an integration between the management consoles and a Git repository of your choosing, so to say, because we integrate at the actual low-level Git command level. Independently of which Git platform you choose, you can do all of this. So if I'm working and if I'm building my robots, and once I commit them to either my local management console, or if I commit them to a development management console, they would then be picked up and inserted into the Git repository and committed to that repository as well. So what we've actually done is we've used all of those Git functionality, and that actually allows us to say, independently of what your Git repository of choosing is, you can do that. Whether it's, well, GitLab, whether it's GitHub if you're an open source fanatic, or if you want to really truly get the enterprise scale, and if you want to use Bitbucket. And for this demo, I'm going to be using GitHub, but the same principles apply for any of the others, whether you want to do it on SourceForge or on GitLab or on Bitbucket. It doesn't really matter. So what we're actually going to see during this demo is you're going to see me interacting with my dev management console that's actually running on my laptop. And you're going to be seeing me interacting with the management console that's running in the cloud in a Docker container on Azure, which is my, well, pseudo production machine. What you'll also be seeing is me interacting with my Git repository. In this case, I'm going to be using GitHub. And what you actually then need is you need to have a bit of connective tissue between those management consoles and the Git repository. And that connective tissue in this case is the RPA synchronizer. What actually keeps the projects on the management console and the repository on Git, depending on the actual branch, in sync, so to say. So we are connecting the dev management console with the dev branch on the Git repository, and we are keeping the production one in check with the main, or maybe even the master branch on the Git repository there as well. Which actually means, so if you then commit a new robot or an updated robot to the dev branch on that Git repository, you can then have all of the tools that you have at hand when you're working with things like, pull requests and merges on that Git repository at hand to work on that. So you're not depending on anything that we've built or that the Git platform that you chose has built, because it's all an open platform. You can use whatever tool you want to do those pull requests and merges. So this is what we're going to do. So before we actually dive into that, let's have a quick look at what we have today. So we have my local management console, we have my remote management console as seen from the URL, and I have, of course, I have the normal Git website. So you've seen that. So this is the one that you can actually deploy on your machine and have everything local, and the RPA RLM functionality will just work. You can use the more enterprise scale Bitbucket capabilities there, or if you want to have a more integrated approach, you can go with GitLab. I'm going to go with GitHub for this demo, and what I'm going to do is I'm going to start from scratch. So I'm going to sign up for a new account, and I'm going to show you exactly what you need to do in order to get RLM to work. So I'm signing in. I'm going to get a username. Hopefully RPA is still available. Oh, sorry. So I'm going to take, KRPA. No, that's quite unfortunate. Jesper RPA. No. RLM demo. RLM demo is available. So then we have RPA at scherpenhuizen.com. So no worries, I'm going to delete that email address after this. So no worries there whatsoever. I'm always going to use these securely generated passwords for these type of solutions. So again, don't worry about that password. I'm going to remove this this instance after this video. So I'm just going to do all of these things. I need to verify a puzzle. Let me see. Well, verify that then. Pick the spiral. Oh, so that's why I needed to study astrophysics to solve that puzzle. Oh, that's nice. Yeah, just update that. And then we say, well, I'm actually not a software engineer. I'm something other. Sales engineer. How much programming? A little moderate amounts. Well, learn Git and GitHub, of course. There you go. Verify the email address. Verify your email address. There we go. Verify email address. Email was verified. So there you go. So we now have a GitHub account. Well, the one thing that we need to do is we need to think about, okay, so how do we actually connect those synchronizers to Git? Well, for that, we need to use what's called SSH, a private and public key set. So what actually happens is we use our private key to encrypt all of the communication between the Git repository and the synchronizer, and then of course the Git repository, or in this case GitHub, has our public key to make sure that we are indeed, well, RPA at scherpenhuizen.com that's doing that interaction there. So what I'm going to show you right now is I'm just going to show you how you generate those key sets. You can use all kinds of SSH tools for that, but we actually include it with the product there as well. So the first thing I'm going to do is I'm going to go to the bin folder within Kofax RPA, and then I'm going to run the synchronizer commands with some extra parameters. So synchronize.exe -g, and then where we want to have the actual keys present. There we go. So it's now generating those keys, and we can then use them going forward to authenticate ourselves to GitHub. So there you go. So if I now do more c apps docker /id id rsa.pub, this is our public key that we can use. So we can actually just copy and paste this from here and onto the GitHub. So I can go here, and I think I need to go to settings. Yes, here we go. So here we can actually publish our SSH ones. So the key that I have right now, that's the one that's going to authenticate the communication between my local management console, so the dev environment, and I also have the public key for the one on Azure, and you'll see that straight away after this. So here we go. This is local. Add that key. So then I also need to have the public SSH key for my connection between the production environment and the repository. So I have that here with me. So I can just do that like that and say that is the prod key. There we go. So we submit that. So we have the local and the prod. So that's actually going to authenticate both synchronizers that are going to be running against this environment. So the next thing I need to do is I need to start creating an actual project or an actual repository. So here we have the option to do that, and we are called RLM demo. So this is going to be my first repo, and I'm going to make it private because there's nothing there for anyone else. So I'm not going to do anything with the readme, a git ignore, or a license. You can always do that afterwards. So I'm just going to use that. So there we go. So this is our first repository. So what I'm going to do is I'm now going to go into my production environment. So here we go. So this is the one that's running on Azure, and I'm just going to create a new project for that. Before we do that, make sure that you have a set of credentials for the actual synchronizer. So here we have Wally robots, and that's part of the synchronizers group. That's actually the credentials that we're using for the synchronizer to interact with the management console. So make sure that you have that, and if you then start to create a new project, let's do that. I'm going to call that first repo, and from a permissions perspective, we need to add the VCS, version control system service user, and I'm going to connect that to the synchronizers. I'm going to create a group for project administrators, connect that to developers, and of course also an actual developers group there. Okay, services, we can of course indeed activate them if we want, and then we get into the actual repository. So here we are actually going to enable the configuration, and we need to grab the URL from GitHub, and it's actually right there, and we want to have the SSH one. So I'm just going to click this one, go back to the environment, put it there, and I'm going to put master in as the branch for the production environment. So I'm going to put it in read-only mode because this is going to be production. So you're never going to make any sort of changes to your robots in production. And if you do, you don't want them to corrupt your version control system, even though Git is perfectly capable of managing those sort of things. But I'm just forcing it to be in read-only mode. So it's only going to be reading from Git, and well, pulling the robots out of there and deploying them here on my management console. And the thing I'm interested in is, of course, robots and maybe resources. I don't want to worry about schedules or auth credentials. So there you have it. We now have that running. And of course, the synchronizer for production is already running. So what you'll be seeing in a few seconds is that this system will actually be touched, so to say, by the synchronizer. So I'm just going to renew that, and as you can see, it's now been touched by the synchronizer. Okay, that's absolutely beautiful. So the first thing I can then do is create a dev branch. So we have the master branch, and we now also have a dev branch, and that's actually the whole thing. So when we create something in development, we're going to push that to the dev branch, and then you can have all of the capabilities that Git offers in place to pull those changes into the master branch in order for that to be then deployed to production. So that being said, I'm going to do the exact same exercise on my dev environment. So we have the admin, I have some users here. So I've got Jesper and Daniela, and they're going to be our RPA developers. And I have my project here. So I'm just going to create a new one, and that is again first repo. The permissions are almost exactly the same. So I have a VCS service user. That's the group called Sync. I've got a project administrator. I'm just going to use the developers for that. In a real world scenario, you'll probably be using distinct groups for both of them, but this is of course just a demo. I want to enable the environment there. We can make some other changes, and then here we can actually do the exact same thing, but now instead of putting it in master, we're just going to be pushing it into dev. So because we are going to be actively developing on this environment here, I don't want to have read-only checked. And I do want to mark both robots and resources because that's what production is expecting from us as well. So there you have it. So now the only thing we need to do is we need to activate this synchronizer, because this one was already running, because it's also running on the cloud. And if you remember, we did generate the private key for that synchronizer as well. So if we then go back to my environment here, I'm just going to grab the right command. There you have it. And this is of course just the actual execution to save the settings that we want, and after that we're going to start the actual synchronizer. So we're going to say, well, we're going to configure the synchronizer, we're going to tell it where the management console is, we're going to tell it which username and which password to use, and of course this is just a local one, so it doesn't necessarily need to be that secure. The interval between which the synchronizer needs to check for any changes, no host key, and that means that we don't actively check whether the GitHub server is indeed GitHub or not a man in the middle. And then we also have the private key that we generated during the actual generation of them. So we can then use that. I'm just going to press enter, and it's going to store these pieces of configuration, and then we can actually start the synchronizer. There we go. And then we can just say, well, there you have it. So we now have everything locked and secured. So let's open up a design studio, shall we? So there we have our design studio. So just to show you that I'm currently connected to the management console as user Jesper, and I have the first repo project right there, so I can now download that. There we go. And let's build some robots, shall we? So what I'm going to do is I'm just going to build the simplest robot there is. So I'm just going to say, well, I'm going to create a new web automation robot. I'm going to put it in a folder. Let's call it robots. Create a new one, new web automation robot, and call that first robot. And that robot is going to do nothing else than just to open up a website. So I'm just going to prepare execution, and I'm going to say, let's do CNN. Open up CNN. So that's the first robot that we have. Just save that. I would just close that. And what I can then do is just synchronize it with the management console. And this is where you also want to include commit messages. So I'm just going to say first version of CNN robot. Very tight. And I'm just going to submit that. So that's submitted. So once I've made this change, then once every 10 seconds, the synchronizer will pick this up and then submit it to GitHub. So I can now go to GitHub, and you can already see that they said, well, dev has had recent pushes less than a minute ago. So it's now asking me to compare and to create a pull request for that. So you can see that here we have our robot definition, and as all of you know, a Kofax RPA robot is nothing else than an XML containing all the instructions that we do. So we can actually see where the actual opening of cnn.com actually is. That's right there. So this is going to be a very nice one. So I can actually just say, well, okay, that's great. I'm going to create a pull request specifically for that. There we have it. So we now have that pull request, which actually means nothing else than we're going to pull this into the master branch. So here we have the pull request. You can have everything there, and of course this is the first version, so there's nothing special there. So we can just merge that and confirm the merge. So we'll now see, if we go to the actual code, that merge one was also pulled into the master branch, which now also means that if we go to the remote one and go to the repository, we'll see no robots there yet. But if we wait a couple of seconds in the first repo one, there you have it, the first robots. And if we then enable some additional fields there, you'll see that we have Jesper who created it, Jesper who modified it, the commit message there as well, and also the revision number and last modified date. So we were able to use GitHub to actually promote that robot to essentially to a master, to a production robot. So let's do that again, but now I'm going to log in as Daniela. So I'm just going to grab the changes there. I'm just going to log in differently. Hold on. There we go. So you then might say, well, Danielle is also going to create a new robot. She's going to create a robot, and that's called second robot. There you go. Finish that. And that robot is essentially doing nothing else than doing nothing. So we have an action step. Select the actual action. And that is, whoa, come on. It's not that hard. There we go. Do nothing. And we just save that. But the thing she's also going to be doing is she's going to create and, well, actually work on a new version of that first robot. So instead of opening up CNN, we're going to open up msnbc.com. And then, of course, execute that. So once that change has been done, and maybe Daniela needs to do some development tests here, we can just save that, and we can then again submit all of these to the management console. So this now means that we have two versions of that first robot, and we have a new we have a totally new robot there as well. So if we then go to the repository, you'll see that we now still have that first version of that robot there. But we also, if we then switch to the dev branch, you'll see that we have two robots there. So we have first robot and second robot, and Daniela didn't put in any commit messages either. So that's of course quite unfortunate. So what we can now do is we can do a compare. So which would actually show us, okay, what's actually different between these two. And you'll see that for the first robot, it actually says, well, it used to be CNN and now it's MSNBC. And then the second robot, that is totally new. There you go. So we can then say, again, we'll create a pull request. But before we do that, let me just show you that we still have that first version on production. So this could still be running, and at the same time we're testing the changes Daniela just made. And once we're happy with those, well, actual tests, we can then create that pull request, create it, and once it's done, we can just formalize it, actually merge it and pull it into the master environment. So it's being merged. We can have a look at the code, and you'll see that in the master we now have two robots, both of them. So this is now the one opening MSNBC, and this is the one that does nothing. So what we've actually seen now is that we have a very easy way of combining industry standard capabilities in regards to version control and repository management that we can now leverage as part of an overall RPA or hyperautomation initiative. This is of course going to be driving a lot of those initiatives where we saw organizations using Git already for robot management, but where they had to do it either manually or by a bespoke approach that they thought of. Now we offer this as an out-of-the-box integration that we have. So we saw exactly this happen, where you had a change being made right here in development that was pushed to Git, and then we did the actual merging within Git and the pull request and everything, and then we saw it being deployed to the main or the master branch there too. So I hope you really learned something from this and you saw how easy it is to set this up. It's not something scary, but it's gonna really help you in the long run if you really taking robotics to scale seriously. You will need to have something like this in place, because it's all quite nice and dandy if you've got 5 people working on your robots, but just imagine if you've got a couple of hundred or maybe even 1,000 people working on robots at the same time. You'll need to have something like this in place. So as said, I really hope you enjoyed this. If you have any questions or comments or feedback, make sure to either leave that in a comment or reach out to me directly. You can do that on my Kofax email or on my private email, whatever you would prefer. And as always, if you like this video, press that like button. If you didn't, press the dislike button. Comment, like, subscribe. Those are the things you have to say on YouTube. So without that, I would say have a great day. Thanks for your time. Cheers.